In this video, I'm going to take you through the unboxing, assembly, and setup of the Creality Ender 3 V3 Plus, and then we're going to get to a bunch of example prints, slicer settings, upgrades, and more. And as always, I'm trying to make these videos as thorough as possible to really take the time to test the printer and provide you guys with the most value. And that means I'm usually late to the party releasing these videos much later than the printer release date. And that's again because I'm not trying to rush through these videos. So with that said, we've got a lot to get through, so let's get started. We'll begin here with the unboxing. If you guys have watched my other video about the standard size or smaller Ender 3 V3 Core XZ printer, this will look very familiar because it's almost the exact same set of parts with the exception of a few small things. Everything is packaged very well, and on the top piece of foam you'll find all of the extra parts and accessories. Below that you'll find the gantry and a sample roll of filament. And below that is the base. And when you get it all unpacked, you'll realize that mostly everything is pre-assembled. There's not going to be a whole lot to do in terms of the assembly. In terms of the components that are not pre-assembled, a lot of it is all of the familiar parts, including the power cable, some sample filament, spool holder, one odd little piece here, which we'll get to a little bit later, as well as these reinforcement tie rods, and then the standard tools and accessories. Now we can turn our attention to the assembly, and as I just mentioned, this is going to be fairly straightforward as mostly everything is pre-assembled. We've got the base at the bottom sitting flat on the table, and then we've got the gantry, and on either side of the base there are two slots that the gantry will fit into, and you can just slip those in. Make sure you've got them facing the right way, so the Creality logo on the gantry should be facing the front of the machine. In the included hardware bag you'll find a bunch of these M4x8 button head cap screws. And on the left and right hand side of the machine, while it's sitting on the table, you'll be able to fit two on each side. Then you'll have to flip the machine onto its side, and from the bottom you'll see again on the left and right hand side, two more spots on each side for more of those M4x8 button head cap screws. The V3 Plus is quite a tall machine, so they've included these reinforcement tie rods that are marked L and R for left and right. And if you look up at the back of the gantry, you've also got labels there, L and R, so obviously you are going to match the tie rods to the labels on the gantry. When securing the tie rods to the top of the gantry, make sure that you put the eyelets on the outside. Do not put them on the inside. And again, you're going to be using more of those M4x8 button head cap screws to secure them in place. And down at the bottom of the tie rod, you'll find a hole at the side of the frame where we can secure another M4x8 button head cap screw, and the same thing on the other side of the machine. Now, if you do find that one of your tie rods is too long or too short, in this case I had one that was slightly too long and I couldn't get the M4x8 button head cap screw up at the top secured in there, you'll see that the tie rods are adjustable. You can take a wrench and you can loosen off the nut just below the eyelet, and then you can thread the eyelet either in to make it shorter or thread it out to make it longer as necessary. I would only do a half turn at a time, and once you find the exact spacing that works for you, you can then insert and tighten your M4x8 button head cap screw and then tighten down the nut, securing it back in place. After that, we're going to be attaching the touchscreen, and you'll find the touchscreen in a protective bag. At the back of the touchscreen you'll find an electrical connector. And it's pretty obvious here that at the front of the machine, you have the mating connector, and once you remove the plastic strip holding it in place, you'll be able to pull it free and connect it to the back of the screen. And you'll also line up the two slots and grooves with the two tabs on the back of the touchscreen. You'll push that into the machine and then push it down to lock it in place. At the back of the printer, you'll find a few more electrical connectors that need to be taken care of. On both the left and right hand side, you'll find these connectors here that have yellow tags on them labeled Z, and they'll both get plugged into the Z motors. Now technically these are Z and X motors because of the Core XZ motion system, but we'll let that slide. And on this side you'll find one additional small black connector for the upper Z limit switch, and you can just make that connection. The connectors are all keyed so you can't plug them in backwards. Back on the other side of the printer, we can start routing the wire harness exiting the side of the 3D printer. And this is the harness that will find its way up to the print head. It has a bunch of stickers on it with labels, and some of those labels have depictions on where to put the wiring harness and secure it in place. There's these hooks where the wiring harness will push into at various locations on the frame. And there's a white 3-pin connector that plugs into the filament runout detection sensor on the moving gantry. At this point, we can also insert the PTFE tube into the push fitting connector at the top of the print head, and finally plug in the wiring harness that goes to the print head. The plug is at the back of the print head, and there is a strain relief bracket. There's 2 holes in there where you can fit a zip tie, and you can tie down the wiring harness. And then in the hardware bag, you'll find this small black clip, which is a strain relief clip for the harness at the back of the print head. In the hardware bag, you'll also find these small black PTFE tube and wire harness clips. The hole is where the PTFE tube can get passed through, and the open C-shaped clip portion pushes and friction fits onto the wire harness itself. And now these 2 things will move together, and the PTFE tube will provide some rigidity and structure to the otherwise floppy wire harness. On the right hand side of the machine, you'll find 2 shoulder bolts sticking out, and this is where the spool holder bracket gets pushed into, and then the spool holder itself threads into the spool holder bracket. And before you power on your machine, very important, there's a sticker covering a hole on the left hand side of the machine for the voltage selection for your power supply. Select the proper AC voltage for your region. There's a reminder also on the front of the touchscreen, otherwise you could damage your printer if it's not properly set. With the assembly now done, we need to set up the printer for our first print. And to print anything, of course, we're going to need some filament, so we can load some filament onto the side of the spool holder. It should be looped down and up into the filament runout detection sensor, and we'll load that in a moment. But one of the odd things that comes with the printer is this anti-tangle bracket, and this is something I've only seen on the V3 and V3 Plus. It fits around the spool and clips to the spool holder, and it's supposed to prevent the filament from backfeeding and getting tangled. We'll talk about it a little more later in the video because I do have a better solution. As you can see, it can kind of wobble around. It's a little bit awkward. For now, I will use it, and you can see at the bottom, the intent here is that they've got this spring-loaded bar that the filament will get pressed up against, and that will prevent it from backfeeding, but it tends to push the whole spool up and make it wobble kind of awkwardly. Now we're ready to power the machine on, and on the touchscreen, you'll be greeted with the Creality splash screen. You'll be able to select your language, agree to the privacy policy, set up your network, set up your time zone settings, bind your printer to Creality Cloud if you're interested in that, and then the printer will go through the self-check and self-calibration process. Part of this calibration process is something called input shaping, and this will cause your printer to loudly vibrate, and this is totally normal. And during this process, I would highly recommend that your printer is on a very stable table or surface. And in the last step, the printer will perform the auto bed leveling, where it will probe the print bed to measure it. And finally, you may be greeted with a firmware update like I was. And with that done, I can tap on the nozzle icon on the main screen. I'm going to type in 225 degrees Celsius, and that should be enough to load some PLA. The nozzle will heat up, and I can remove the PTFE tube by pushing down on the PTFE tube fitting and pulling up on the tube. Then I can push the filament through the rest of the tube till it pops out the other side. I can unlock the extruder using the extruder lever arm, push the filament all the way down to purge and load it. Then I can lock my extruder arm and push the PTFE tube back in place. Now that we're done with this setup, I want to take a quick moment here and talk about some of the features that are unique to the Ender 3 V3 series. That includes, of course, this V3 Plus. These printers are very unique to the Ender 3 family and just generally the Creality lineup as a whole. And so the biggest deviation from all of the Ender 3s of the past is this Core XZ motion system. The Z axis is now belted, so at the back of the printer you'll find 2 vertical linear rods and the belts, but what you won't find are the traditional lead screws. This should eliminate Z banding and Z wobble artifacts. On the Y-axis of the V3 Plus, you'll find Creality has gone with some very beefy 12mm linear rods, whereas on the regular size V3, they're only 10mm rods. Coming off the back of the print bed, you'll also notice a very robust looking heated bed cable and strain relief, which is nice to see. And if you take a peek under the print bed, you'll find 4 strain gauge sensors at all 4 corners like the K1 series, and unlike the KE, which uses 1 strain gauge sensor and then the CR Touch to do the auto bed leveling. On the back of the print head, you'll find what I like to call the backpack fan, which is essentially an auxiliary part cooling fan. This would be analogous to the giant side cooling fan that's found on the K1 series, but the V3 Plus has no enclosure to attach a fan like that, so instead they put it on the back of the print head. and you can see that it fires from the back towards the front of the machine, and you still have the normal part cooling fan with the 2 outlets on either side of the nozzle. And one final non-functional but fun feature is the backlit Creality logo on the print head. So now that you know what this machine is all about, let's get printing. If this is your first 3D printer and you're just getting started, then you're going to need to download a slicer if you don't already have one. When I first started testing this printer, Creality Print 5.0 was out. Now they have 5.1, which we'll get to later in this video. But oddly, with 5.0, the V3 Plus was already released, and they didn't have a profile for it in Creality 5.0. So I used Orca Slicer. Orca Slicer is very powerful and very popular, and many of the big brand printers are basing their slicer off of Orca Slicer. And if you go into the printer presets, you'll find a preset for the V3 Plus. Now these presets are user generated and they are not official Creality presets, so you're definitely relying on other people's testing, and with a newer-ish printer like this, they'll probably be refined over time, so you'll definitely want to update the slicer now and then to get the latest versions of these presets. But the great thing is it will get you up and running very quickly. So for now, I'm going to use this built-in 0.2mm standard layer height preset, and I'm going to make a few small changes. For example, I've changed the infill density to 18% and the infill pattern to triangles. This is just a personal preference of mine. And as I scroll through all of the other settings, everything else mostly looks fine. Then if I go up to the filament drop-down list, you can see that I have it set to Creality Generic PLA. If I click on the edit icon to the right of that drop-down list, you can see all of the parameters related to this particular type of filament. And in this print here, I'll be using some eSun PLA Plus. So this all looks pretty suitable for the eSun filament. Now I'll go ahead and slice this test print, and the print should take 45 minutes. And I just want to repeat myself one more time here that later in this video, we will be looking at Creality Print 5.1, but at the point in time when I was filming this, that slicer was not yet released. But regardless, even with the Orca Slicer profile, the print seemed to be coming out perfectly fine. The first layer of this test print went down perfect. The auto bed leveling resulted in a very nice first layer, and the rest of the print seemed to turn out just fine. However, on closer inspection, you could see that most of the print looked okay except for those top layers. They were very rough looking, and I was rather disappointed with this result because this was not what I had seen with the smaller, regular size V3 model. The sidewalls looked okay. There was a little bit of banding, but it was actually more of a color change, and that could be related to cooling. I couldn't really feel any ridges with my fingers, but my main concern were those really rough top layers. So I decided to head back into the slicer, and I wanted to increase the number of top shell layers. This can sometimes fix bumpy looking top layers, because as you build up those thicker top layers, it gives the printer more of an opportunity to even them out. With too few top shell layers, some of those layers can sink in between the gaps of the infill, and then there's not enough material to build it back up nice and smooth. And in this case, 4 top shell layers improved the situation slightly, but I still wasn't thrilled about this result. Considering all of these similarities between this machine and the smaller Ender 3 V3 and how well that machine performed for me in the past, this seemed very uncharacteristic of what I would expect from this printer. Now this will get fixed later in the video, but I did want to share with you my initial experience while slicer options were limited. So after those first few prints, I decided to move on to some larger models that just didn't have those flat surfaces. I settled on this model of a Deadpool bust, and that's because I also printed this model on the regular sized Ender 3 V3 in that previous video. I thought it would be interesting to do a head-to-head comparison between these two machines because essentially the V3 Plus is just the smaller one scaled up, and as far as I can tell, the only difference in equipment between the regular size and the Plus machine is the larger Y-axis linear rods on the Plus model, as well as the tie rod reinforcements up to the gantry. So with that model sliced and exported, I used the USB stick to transfer it over to the V3 Plus, and we've got this print started. I'm using the exact same dual colored PLA filament as I did with the print on the regular size V3, but sadly halfway through this print I experienced a power loss in my home. The power was out for quite some time and I figured I was going to lose this print, but I was able to resume the print using the power loss recovery feature on the V3 Plus, and to my surprise, the heated bed heated back up quickly enough that the print was still stuck to the textured build plate, and the nozzle did not break the print loose when it resumed, so the print was actually salvageable. And despite the power loss, overall the print looked pretty good. In this case, the dual colored filament looks like it was changing color in such a way that it was banding in the Z direction, whereas in a moment when I bring in the part printed on the regular V3, the filament seemed to have organized itself where the pinkish side was on the front of the model and the purple was on the back. But you can also see here there's a artifact where the nozzle had paused during the power outage, and there's a pretty noticeable ridge at the layer at which the print was paused and then resumed. Obviously this is not really the fault of the printer. I was just impressed, as I had mentioned earlier, that the print could be salvaged and it didn't break free from the print bed. All the other details came out looking nice, and the steep overhangs under the chin and under his arms also looked quite good. But when I bring in the model that was printed on the standard sized Ender 3 V3, it does look quite a bit better for several reasons. One of them was the arrangement of that dual colored filament. For whatever reason, on the standard size V3, it was a lot neater looking with just the one color facing the front of the print and the second color facing the back, but all of the details were also sharper and the surfaces were quite a bit smoother as well. There was a little bit of ghosting and ringing on both of these models, but this is always more noticeable with these very shiny type of filaments. Now, before performing more prints, I knew I had to do something about this spool holder at the side of the machine and this very awkward anti-tangle bracket. It works okay for some spool sizes, but it's not quite as a universal fit as I'd hoped it would be. Occasionally, the filament can still make its way past the edges of this spring-loaded bar and does still get tangled. Plus, the location of the spool holder itself is a very odd choice considering all of these wires exiting the side of the printer are basically right there, and with the gantry moving, they're oftentimes rubbing against and hitting the spool. It's much too congested of an area and could easily lead to more filament tangles. To solve this issue, I designed a freestanding top mount spool stand, and this is a universal spool stand, so it fits all of the Ender 3 models and even the K1 and K1 Max series. It features a tool holder in the base that can handle all of the tools that you'll find in the generic Ender 3 accessory kits, and your side cutters can be conveniently stored on the bracket above that, very close to the spool, so they're never out of reach when you're about to change filament. I've yet to find a spool that does not fit the spool holder at the top of the mount, and the friction on the spool holder can actually be adjusted. The filament runout detection sensor gets relocated to the top of the frame, and it's mounted on a ball joint, so the filament is always getting fed into the extruder at the proper angle. Relocating the filament sensor is very easy. There are 2 printed brackets plus 1 screw for this setup. On the main bracket, there's a recessed pocket where the ball joint mount will fit inside, and you'll see that the holes in the 2 pieces will line up. Then you can insert the M3x10 thread forming screw into the back, and with that screw tightened down, the 2 pieces will be attached together and the ball mount will be complete. Next, we'll be attaching the runout detection sensor to this mount, but first, of course, we have to remove it from the machine, and to do that, first we can remove the PTFE tube from the filament runout detection sensor, and to do that, you just need to remove the blue locking collar, push down on the collet, and then remove the tube. And then we can remove the connector on the side of the runout detection sensor itself, and then remove the 2 M3 screws from the runout detection sensor, and it will come off. Put those screws aside because we will need them later. Then we can pull out the runout detection sensor cable from the jacket that protects the wire harness cable running up to the print head. There's a split in that jacket that you can use to remove the cable, and you may just have to temporarily remove some of those stickers to get them out of the way so that you can slip the cable through. Now we can install the runout sensor bracket on the top of the printer frame using the 2 included M3x10 socket head cap screws. This is easiest to do facing the back of the printer. You'll find in the back of the frame there are 2 unoccupied M3 female threads. The holes in the back of the bracket will line up with those 2 female threads, and again, using the M3x10 socket head cap screws, you can secure the bracket in place and it will look something like this when you're done. Now we can take our filament runout detection sensor and attach it to the ball joint bracket using the included M3x20 thread forming screws. The 2 holes in the runout detection sensor body will line up with the 2 holes in the ball joint mount, and the thread forming screws will cut their own threads into the plastic and secure the runout sensor in place. And since the ball joint mount can swivel around 360 degrees, there really is no up or down orientation here until you of course feed the filament in, and you'll follow the arrow sticker on the front of the runout detection sensor. And then we can take the included extension cable and plug it into the runout detection sensor. Using the adhesive cable tie clips and the included cable ties, you can start to route the cable down the side of the printer. Keep the cable ties loose at first until you get everything in the place that you want it, and then you can tighten those up. Although I would recommend to leave the very top one still a little bit on the loose side, so the ball joint mount has some room to wiggle around and it's not pulling on the cable. Now we can deal with our runout sensor cable, and we're going to be routing this up the side of the frame. For this, we can simply use another adhesive cable tie clip on the side of the frame. Now because the V3 Plus has a longer harness going to the print head, it is more susceptible to sagging and drooping, so it's going to need some extra support from the original PTFE tube. And so what I did here was designed this printable stand-in for the original Creality runout detection sensor. And you can take the original PTFE tube collet, locking clip, and hardware that you removed from the original runout detection sensor, and you can install those into this dummy sensor. The dummy sensor will get installed onto the X-axis gantry where the original real Creality runout detection sensor used to be. Once you've got the screws in place, you can insert the PTFE tube into this fake runout detection sensor, and you can push it pretty much down to the bottom of the sensor to shorten the tube up a little bit. Then you can install the locking clip, and you can ensure that the PTFE tube is still running alongside the wire harness in such a way that it is supporting it and preventing it from drooping down too low. The end of the tube no longer goes into the PTFE tube push fitting, and instead it gets pointed down and behind the print head, and you should still have full range of motion with nothing getting pulled on. At this point, if you haven't already removed the original spool holder, you can just pull up and away from the machine and it will come off. The stand itself can now be placed beside the printer, and the support legs will slide right underneath the Ender 3 V3. And because the V3 Plus is such a tall printer, you will need to print the longer splice bracket. Links to everything in the video description down below. And up at the top, you can remove the conical retaining nut for the spool, put your new spool on top of the spool holder, and secure the nut down. The filament should be routed up and over the spool and into the top of the runout detection sensor, and then we can take our filament down, insert it into the print head, and now we have a nice direct filament path from the spool down into the top of the extruder. We've also eliminated the spool rubbing against the harness at the side of the printer and all of that congestion down there, which could have led to more tangles with the filament. I have a separate video detailing the full assembly of the spool stand itself, and you guys can find this spool stand on my website, embracemaking.com. On my website, you'll also find these pattern build plates, which are very popular right now. And if you're interested in ordering one for the V3 Plus, just note that the V3 Plus and K1 Max are interchangeable because they are the exact same size. If you haven't seen these before, the pattern that you see on the build plate itself is imprinted onto the first layer of your print for a really interesting look on that surface, and all of my plates are double-sided, so the other side is a regular gold PEI textured surface. So effectively you're getting 2 build plates in one. Now I've got 2 more prints here with Orca Slicer before we migrate our slicing over to Creality Print 5.1. I wanted another fairly large model that would take advantage of the larger build volume of the Creality Ender 3 V3 Plus, and so I have this Stormtrooper helmet, and I've scaled it up 250%. The shape of the helmet doesn't really have a nice flat spot to place on the print bed, so what I'm going to do here is use this trick where I've rotated the helmet into this orientation, and I'm going to place a portion of the helmet below the build plate. This is going to effectively cut off a small portion of the helmet at the back, and I don't think this is a big deal because likely we'll be viewing and displaying this helmet from the front. Now, even with the model in this orientation, we still are going to need to enable supports, and for this I'm going to be using the tree supports, and I've just got it set to auto. And I didn't capture it on camera, but I set the infill to support cubic in an attempt to save a little bit of filament and speed this print up. And you can see that infill type as I scroll through the sliced preview. And this is estimated to be a 10-hour print, and rather than transfer the file over USB, I'll quickly show you guys here how we can do it over Wi-Fi. So if you head into the network settings on your touchscreen and you find your IP address, and then you jump into the internet browser of your choice on a computer on the same network as your 3D printer, and you type that IP address into the top, followed by :4408 /# and that will bring up the fluid interface. In here, we can wirelessly transfer files. We can also click on the Tune tab on the left-hand side, and we can take a look at our bed mesh. We have this nice visualization of the profile of our print bed, and you can see the highest point to the lowest point has a range of 0.6461 millimeters. And this is generally more than what I'd like to see, but what I'm noticing here is that the left-hand side of the bed is higher than the right. So it looks like the print bed is sloped, but I doubt this is actually the case. If I saw this result on a traditional bed slinger with dual lead screws on the Z-axis, I would be checking the squareness of the X gantry with respect to the print bed. And I assume the same thing is going on here, except we don't have those dual Z lead screws. Instead, we have this Core XZ motion system. And what I suspect is going on here is that one of the belts making up that Core XZ motion system is tighter than the other. Now in a Core XY motion system, this would manifest itself as racking, where the gantry is skewed, and if you tried to print a square, it would kind of look like a parallelogram. But with Core XZ, it looks like perhaps the gantry will now be tilted in the Z axis, resulting in a bed mesh that looks like this, but it's being compensated for by the auto bed leveling. So when you go to print, you don't really notice anything, as the first layers will still go down fine. Now all of this is just speculation. Let me know what you guys think down in the comment section below. Perhaps in a future video, I'll dive into this a little bit more. But for now, we'll get back to transferring our Stormtrooper G-code file over Wi-Fi. So back in the home menu, if you take a look on the right-hand side and you scroll down, you'll find the jobs list. We can click on the plus sign to add and upload files, and we can just select the file you want in the window that pops up and upload it. And after it's done uploading, it will appear in the file list as you would expect, and you can just click on that file and select print. And for those of you guys who are new to 3D printing or just not aware, the Creality firmware for these printers is built off of the open source Clipper firmware, and Fluid is one of the powerful user interfaces that you can use to interact with your printer. There are a lot of advanced functions, settings, and parameters that you can mess around with inside of Clipper, and that could be a whole other video on its own. But for now, just know it's one of the ways that you can wirelessly transfer those files to the printer and then start the jobs wirelessly as well. A few moments ago, you may have also noticed here that I changed the filament over to some white Hyper PLA from Creality, and the roughly 10-hour Stormtrooper helmet print went off without a hitch. The tree supports were very easy to remove. There was quite a few of them, so it just took a few extra moments to do that, and once they were gone, the helmet looked very nice. Now, white is not really the greatest color to print with when you're trying to show off the quality in a video, but I just really couldn't print a Stormtrooper helmet in any other color. So I'll do my best here to show you guys the details in the helmet, and I'd give this print the edge in quality over the Deadpool bust. Perhaps the Creality filament is just better quality, or the fact that it's a solid color. I thought the color change banding in the Deadpool bust was a little bit visually distracting, so I'll probably stay away from those filaments when testing these printers in the future. Now at the bottom of the Stormtrooper helmet, there is a stand, and for that, I'm going to try this eSun Magic filament. It's more of a sparkling chameleon color, and it should not produce those color changes at the different layer heights, rather than it just sort of shifts colors as the light hits it at different angles. It should be more visually interesting than just plain solid colors, and I'm using the exact same print profile that I just did with the Stormtrooper helmet in the Creality Hyper PLA. This filament seemed to work just fine on the V3 Plus, and other than those very few spots of some minor stringing, I thought this was the best quality print so far, including those top shell layers or the top flat surfaces that earlier in the video I showed you this print profile seemed to be struggling with. And this model was also scaled up 250% to match the scale of the Stormtrooper helmet, so that of course when we go to put these two things together, they'll fit and look proportional. And if you guys are looking for this model, I'll put a link to it down in the video description below. At several points in this video, I mentioned that Creality Print 5.1 was eventually released somewhere in the middle of my testing and filming for this printer. And And we're finally at the point in this video where I can show you guys what it's all about. And so when you open it up, it does have a similar sort of feel to Orca Slicer. There are some differences, obviously, but that's of course because it was built off of Orca Slicer. Now in the top left-hand corner, you can find your printer, where we can go ahead and add another printer, and you can sort through that list and find the Ender 3 V3 Plus. Now I've dragged in a step file, that's STEP, not an STL file, with multiple bodies. Most of these new slicers will accept step files. And I'm going to go ahead in the top right hand corner and select my material type. So I'm going to be using Creality Hyper PLA. I figured we should test Creality's printer with their filament, with their profile, to see how well they've gone and tuned the print profiles for their own products. Now there are a lot of other filament presets built into Creality Print 5.1, as you guys might have seen in that drop-down list. So even if you're not using Creality filament, you probably have a pretty good starting point for whatever it is that you are using. Now in the actual print profile, not the filament profile, I'm going to be using the 0.2mm standard settings, just like I did in Orca Slicer. And by clicking on the icon with the 3 lines, you can bring up more advanced parameters. And then with those little tabs on the left of the settings window, I've navigated over to the support section and enabled the tree supports. And when I've gone and sliced this, one thing I've also noticed is that I wanted to change the infill settings. So in the second tab, I can now change those, and I'm going to change it over to triangles. Again, this is just a personal preference, just not a big fan of the rectilinear or grid pattern. One other thing that I noticed that I wanted to change was the number of wall loops. So I'm going to increase that to 3, and I want to get rid of the brim. And rather than scroll through all the settings, if you do know what the name of the setting is called, but you just can't find it, you can click on the magnifying glass to search. So I'll search for brim. I'll click on the entry that comes up, and I'll change it from auto to no brim. Then I'll go ahead and reslice this, and we'll do a quick check on the preview. And if everything looks good, we'll be ready to send this off to the printer. And as I'm editing this video, I just realized I did not capture sending files to the printer wirelessly using Creality Print 5.1. So if you click the land printing button in the bottom right hand corner of the screen, it'll bring up this pop-up window with a drop-down list of a bunch of available printers. It seems like it has the ability to detect Creality printers on the same network as your computer, and you can just select that printer and then click on send G-code, or click one-click printing to start the print immediately. There also appears to be a multi-machine option, which I assume will send the same file to multiple printers simultaneously. Now I haven't tested this option, but that would be very useful for a print farm. With that out of the way, we could resume the robot hand example. And before starting the print, I'll change the filament over to the Creality Hyper PLA series in red on the Universal Spool Stand. And for those of you guys who are very observant, you may have also noticed earlier in the video this LED light bar. It's another functional and useful modification that I've made available to many of the Ender 3 models, including the S1, SE, KE, V3, and V3 Plus series. I'll put a link to that video in the top right hand corner of the screen. Now as this print was running, using for the first time all of these settings with Creality Print 5.1 for their own filament, and for of course the V3 Plus, everything was off to a good start. And when the print was finished, I noticed that the print quality was more along the lines of what I had expected from the beginning from this printer based on my previous experiences with the smaller, regular sized Ender 3 V3. The first layer of this print looked really nice. Now, the design of this print does require all of these tiny little hexagons to be supported. So there's quite a bit of that support material that does need to be picked out at the bottom. But each of those tiny little hexagons adhered to the build plate perfectly, and none of them were fused to the body of the part. So that was a very good sign, and the rest of the surfaces that were built upon supports looked really nice. Now on the top surface, of course, you do get those steps because of the angle of this print, and we were using that 0.2mm profile. But all of the sidewalls also looked very respectable, especially considering the harsh light that I'm showing you guys these prints under. Here I'm showing you another surface that was completely built on top of supports, which again looks good. And on this part here, the perimeter walls did have some ghosting and ringing where there was the stop starts for those details on the side of this part. So that could definitely be improved upon, but the top shell layers were so much better than what we'd previously seen with the Orca Slicer presets. Now many of these parts are intended to fit together like these two here, and the fit on this male and female spline was appropriately snug. Now I didn't design these parts, but I would imagine that the design intent here is that when these things fit together, they're not supposed to just fall apart, as you'll see in the assembly at the end. I went on to use the same profile in Creality Print 5.1 to produce all of these prints, which are parts of an assembly making up a very cool articulated robot hand. And I decided to print 2 full sets, one in the red Creality Hyper PLA and another in this eSun EPLA Chameleon. The results with the EPLA were really nice at first using the Hyper PLA profile in Creality Print 5.1, but eventually I did notice that I was starting to get a partial clog in the nozzle. Now, I was able to clear that partial clog, but traditionally I found that these semi-transparent type of filaments do require hotter nozzle temperatures, so I bumped that up about 10 degrees to 230 degrees, and I never had that problem come back. In the collection of parts for the robotic hand build, there are some small models of these little microchips, and for that I'm going to be printing in Creality Hyper PLA, again, this time in black. For these, again, I'm using the standard profile in Creality Print 5.1, and the Creality Hyper PLA Black was the most impressive result that I've gotten with this printer so far. The red Hyper PLA is quite a bit more glossy than the black, and this tends to highlight more of the print imperfections. The black color was quite a bit more satin finish. Now, those parts are very small, so I was happy to see that this printer has no issue printing very small details. And you can see here how these small microchip parts fit into the overall design of this robotic hand. And if you're wondering how I got the pins of that fake IC to become silver, I just colored over them with a silver Sharpie marker. And so I'll briefly show the assembly of this robotic hand, and you can begin to see why I printed 2 full sets of these parts in different colors, because I'm going to be mixing and matching them just to make the final result look more interesting. And while I'm doing this assembly, you can also get another look at the quality of some of these parts and formulate your own opinions of this printer and what it's capable of. If you guys are looking to print this very cool model, you'll find a link to it in the video description down below. The designer did a very nice job with all of these splines, pins, and clips that hold all of these articulated joints together. I love stumbling upon designs like this where you can clearly see that the person has put a lot of thought and effort into it. There were only a few instances with some of these smaller joints where I had to make some adjustments to the printed parts to get them to fit properly, but again, these adjustments were very minor. The articulated robot hand sits on top of this base that looks like a very large gear. This base can be screwed to a wall or surface, and then you can rotate the wrist around to position the hand in any orientation you want. So shout out to designer Make-A-Print for this very cool model. Again, I'm going to put a link to this down in the video description below. He posted the model to Printable, so go show him some love and go like that model, perhaps even print one of your own and post up the results. Now, I couldn't just stop there with the test prints after seeing those very nice results on the small parts using the black Creality Hyper PLA. So I decided to print a bunch more parts using this material, and again using the default profile settings in Creality Print 5.1. I needed to see what the results would look like on larger prints rather than just those very small fake microchips in the previous example, and I was not at all disappointed. All of these prints with the black Hyper PLA have been by far the best results on this printer. Now, of course, it could have something to do with the color and sheen of the black material versus, let's say, the red, but even factoring that in, it looks like Creality really did their homework with the settings for their Hyper PLA. After those smaller to medium-sized prints, I decided to move on to print something a little bit larger. I've got this necklace holder here that I designed, and although it looks like a vase mode print, it's not 1 layer thick. I hollowed the part out and designed it to be 2 layers thick so it could be a bit stronger. So this one here also came out looking very uniform, and I was very impressed with the results. Now, I've only more recently started using some of this Creality Hyper PLA. Traditionally, I use a lot of the eSun PLA Plus products, and so I have to do some mechanical tests on this material before committing to using it long term. And I'll likely do a video on some of those mechanical tests in the future, so if you guys are interested in that, be sure to subscribe. However, in the meantime, parts that I'm printing that don't have very demanding requirements for mechanical strength, this stuff has been very hard to beat for its visual properties, at least coming off of the V3 Plus and even the smaller V3s, as I've tested this material on those too. So if you have one of these printers or you're looking to pick one up, I would recommend at the very least trying out the black Hyper PLA. With this filament, I was able to get the clearances between these two parts down to 0.15 millimeters between these walls, where the parts would fit together with virtually no play and they could still slide across one another. And as the last sample print, I printed 4 of these models here that spanned across probably 70 to 75% of the build plate, and none of the corners lifted. And these were done in black eSun PLA Plus, so you can kind of do a comparison here between the Creality Hyper PLA in black and a different brand. And these were printed using the Hyper PLA profile in Creality Print 5.1, and the material is a bit more glossy, so you can probably see more of the print artifacts, but even still, it's very apparent that the Hyper PLA prints a lot more uniform, and Creality has definitely tuned that profile very precisely for their own filament. And so that wraps up all of the test prints, and I really enjoyed my time with this machine despite getting off to a mediocre start with it. And that's the first thing that I'd like to talk about. It bewilders me that Creality would release the hardware without having the print profile ready to go in Creality 5.1 at the exact same time. Now, it's probably only a few weeks between getting the printer and then seeing that update for Creality 5.1, but during that period of time, there was probably a lot of users as well as reviewers who may have had some bad first experiences with the printer because they would have to develop their own print profile for it. Now, more advanced users would be able to troubleshoot their way through that, but beginner users would probably have a rough time, and I just don't understand why Creality would risk that negative attention during the product launch phase. And that's really too bad, because this is a very capable machine, and I do understand that right now there's a lot of fierce competition between some of the bigger brands trying to constantly release more impressive printers all of the time, but in my opinion, they should be releasing the hardware and the software at the exact same time. Now, eventually I did get some very impressive results using the Ender 3 V3 Plus print profile in Creality 5.1 using the Creality Hyper PLA. And in this way, I do feel like Creality did redeem themselves because the results were so good. But of course, during this review, I did have to show you the earlier results. Now, in terms of who I'd recommend this printer to, obviously anybody who needs a larger build volume, you could definitely print a helmet or larger cosplay items on this machine in one shot. And the nice thing is that the whole build surface is usable. In the past, there have been some larger printers that were released where even though they had a large build plate, only a smaller portion of it was actually usable because of a warped bed surface or perhaps poor implementation of the auto bed leveling. But I'm happy to say that I ran a bunch of first layer tests on this printer here, and it succeeded in laying down a very nice uniform first layer across the entire build surface. And the other thing that can impact first layer adhesion is how uniform the print bed heats up, and sometimes on larger build plates, you can see cold spots. So I used a thermal camera on the V3 Plus, and everything looks very uniform, so I don't have any concerns there. And while we're on the topic of first layers and bed leveling, earlier in the video, I pointed out that the bed mesh looks a little bit tilted. Now, I theorized that the Core XY system could have one of the belts tighter than the other, and that could lead to the gantry getting racked. Now, the auto bed leveling does compensate for this, so it prints fine, but this is something that I'm going to have to investigate a little more later, and it would just be nice if this is the case that it wouldn't come from the factory like this. And finally, I was really happy to see 12mm linear rods on the Y-axis. The regular sized V3 has 10mm rods, and I was hoping that Creality would make that step up on this machine, so I'm glad to see that they delivered there. I made a previous video about the Ender 3 SE and KE models that only came with 8mm linear rods on the Y-axis, and I did a custom upgrade to 10mm rods on those machines, and it made a world of a difference. So I'm very happy that on the V3 Plus, it does not seem that you'll need to upgrade this machine in that regard. So that's it for now. This printer here will be heading to my print farm for some long-term torture testing. And right now I've got 5 of the regular size Ender 3 V3s there, and 4 of them have been running great. One of them did give out a little early with some print head issues. Those are getting fixed, so hopefully this one stands the test of time. Thanks for watching right to the end. Be sure to check out my website, embracemaking.com, if you'd like to support me, my channel, and my work. And I would love if you guys hit that subscribe button so you don't miss the next video. I've always got new stuff in the works, and I would love to see you guys in the next video.